So now we move to Palermo, and Dr. Fabio Cardona will be presenting to us the pilot in the University of Palermo. So Fabio, the floor is yours.
Good morning to everybody. My name is Fabio Cardona. It's a very pleasure to be here today for me in order to represent my university, University of Palermo, me and my colleague Federica Fernandez. And now I just have a look to our pilot. My congratulations for the previous presentation. I hope to be maybe at the same level. Okay. The challenges that also Shadi told us before of the European Union is to use the thermal energy that we have in particular countries, which are the ones with the climate, which is a Mediterranean climate. So we want to storage this energy that usually in summer we cannot use because we have not the final request. Okay, you can see all the countries with hot summer, and so the possibility to use this hot. So the idea of European Union, the challenge is also to coupling two kind of system, the Borehole thermal energy system, also with heat pump, in order to have a system, a polygeneration system, maybe which can reach a standalone system, a renewable energy system, which can be a standalone system. Okay, this is the idea of our project, of our pilot. On the right, you will find the building number 9, the building of our university, Department of Engineering, department with several buildings. This is my buildings. My room is ubicated there. And we want to create our pilot in this area. You can see the existing solar distilling. This is an ancient pilot which was realized, and we want to dismantling, we want to removing, because it's for us an ancient technology, and we want to study another system, and so we want to remove this one, and we want to put a solar collector and at the same time photovoltaic collector. We will see later on. Then the position of Borehole thermal energy storage in the soil, which is very close to Borehole thermal energy system, coupled with a ground heat pump, is a water-to-water heat pump, and with the heat exchanger, which can use also for exploit air and water at the same time. And the building that you see on the right is the building that we wanted to supply with thermal energy, with the cooling energy, and with electricity which goes to the heat pump and not for light of the building. It's the acoustic building laboratory. Okay. Just have an idea of our plant. First of all, we have the solar collector, and we will see later exactly the shape, the kind of solar collector. Then we have a first thermal storage, which is outside of soil, which we need this one to discoupling the thermal storage from Borehole thermal energy storage. Then we have the Borehole thermal energy storage, a system with a deep of about 15 meters. It's different from Beirut because we don't want to reach the aquifer, okay? And we studied the soil of the University of Palermo, and we cannot go over 15 meters. Then we have the heat pump. Is a water-to-water heat pump. Is an hybrid because on the primary side we can work with water and also with air, because we have better condition using air in summer in terms of COP of our heat pump. Then we have another thermal energy storage with external thermal energy storage. Also, this one is used to decoupling the heat pump from the building, and then we have the building. The setup of the building, we want to reach a temperature of 20 degrees, obviously in winter, about 25 degrees in summer. And the idea is to reach about 45 degrees for water which go to the heat pump, which go to the Borehole thermal energy storage, and about 7 degrees for cooling system. Then just have a look to the different condition in summer. In summer, the idea is to charge the Borehole thermal energy system, and also to supply the cooling request of the final user of the building with the heat pump. Then in winter, we use the heat pump with the Borehole thermal, with the water which comes out from the Borehole thermal energy storage. We have to remember that the heat pump cannot work with a temperature which is higher than 35 degrees. So I reach the water comes out from the Borehole thermal energy storage, and I have to pay attention to this level, okay? And then I use the heat pump to cover the final request, but I have only to reach the difference of temperature between the water which comes out from the Borehole thermal energy storage, and so the consumption of the heat pump is reduced respect the normal condition. Then in summer I use the heat pump, but I use the heat pump to cover the final user, the cooling demand, using another heat exchanger, and because I want to exchange with air, because the air temperature outside is better than the water which comes out from the Borehole thermal energy storage. So this is the main idea of the management of this pilot. Just have an idea of what I want to buy. I want to buy this kind of solar collector. I contacted the industry. Is a 7 module. You see here the 5 module, but I want to buy the 7 module because I want to remove two mirror on the left and 2 mirror on the right, and to put 4 photovoltaic panels, because I want also photovoltaic energy, and I want to exploit the solar system tracking, because it's biaxial solar system, to increase the production of thermal energy and also the production of photovoltaic energy. Okay, so this is the solar collector. This is the heat pump. We identified this heat pump is about 16 kilowatt of capacity, but it can reach also 20 kilowatt in particular condition. It depends. And also we put an heat exchange more, because I want to use also the air, the external air in particular condition, in order to increase the efficiency and to satisfy the request of the final user. Okay, this is the Borehole shape. All of us discuss about the hexagon shape. We have already realized one Borehole thermal energy storage at the University of Palermo. It's very similar, 15 meter deep, and we also study for 2 years. So for this technology, we are sure to have no surprise in these terms. Okay, we also use it Transys for the simulation of models. Also, Antonio Rosato from Naples and Giovanni Ciampi give us an hand in this field. And this is the building that we study. First of all, we study a standard building, which is very similar to our building, because the idea to study exactly our building in the next research scholarship, the girls who won will study exactly our building, but it's very similar. We divided in 5 zones. 4 are on the perimeter zone and 1 in the center, the coral zone. And you can see the condition of windows and of wall is very similar buildings in Sicily for office, and very similar, I have told you, of our laboratory, of acoustic laboratory. Okay, this is the heating and cooling demand. This is a cumulative curve, but it's not load duration curve. This is a demand in terms of capacity and also in terms of energy. And you can see the request of thermal energy in winter and also the cooling energy in summer. And this replaced then in terms of energy. And we put the condition of 20 degrees for winter, 25 degrees for summer, as told before. Okay, let's go very quickly on the transit model. This is the different types that we put inside with all the systems, the Borehole thermal energy storage, the solar collector, and so on. Okay, just have an idea of the parameter that we study for each system. We use for the solar collector the direct normal irradiance in Sicily, and we use meteonorm systems in order to have a direct normal irradiance, and also the different temperature between the mirrors, the temperature on the mirrors, and the temperature of the air, which is very close to the mirror. Then we have also a battery in order to storage electricity, which is enough to cover the heat pump in some days. Then we have the heat pump. The heat pump, we focus on attention of speed of compressor and also two different temperature, the temperature of source and the temperature of the water which comes out from the borehole. The temperature of source, which can be also the temperature of the external air in summer, when I prefer to use in order to increase the COP of heat pump. Then we have the storage tank. I told you about the level of temperature of 45 degrees when we want to charge the Borehole thermal energy storage, and also the cooling temperature of about 7 degrees when when the water go inside the borehole, and then the condition of the building of the small office. This is the first Shadi. I don't want that Shadi can be angry with me for this first result, because this is a simulation for 5 years. Because I want to underline this condition. I'm joking with Shadi, because the idea is to shift up this result, because you can see first of all, just have a look at temperature. The big one is the temperature of the water which comes out from the solar collector, and we see about 45 degrees, while the temperature inside the borehole is very lower than 45 degrees. So I want to shift up these curves. Then we can see the temperature. The red one is the temperature of the borehole, and we are more or less about 22.5 degrees. And this is lower, but I want you to remember that I cannot go over 35 degrees because the heat pump cannot functioning. Okay, so I want to shift up, but not so much. Then you can see the discharging phase. Okay, so first of all, the first year I used the heat pump to cover all the demand of the final user, because I have nothing inside the Borehole thermal energy storage. I want to charge for the first year, and you can see the phase of charge, and then I discharge, and I became to use the thermal energy which comes out in order to cover the final user request with heat pump. And so it's the same for the 5 years. So we wanted to continue the model with Transis, our study, or our management, in order to shift up this course. Some information that I've already done, because we have the phase of discharging from December to March. We have the phase from April to October to charge. This is usual for everybody. And just an important information, if we want to see of the thermal energy that we collect inside the Borehole thermal energy storage, is about 15,000 kilowatt per year. Okay, and our Borehole thermal energy volume, cubic volume, is about 1,300. Okay, I saw that yours is about 1,600, 1,600 more or less, but you have 100 square meter of solar collector. My solar collector, our solar collector is about 26 square meters, is very smaller, because I have to use money to cover solar collector, heat pump, battery, and so this is the first pilot. You told before, this is a pilot, okay? We study, then we want to implement maybe for industry, okay? This is the result, and it's important to underline that we referred only to one zone, and the result is for only one zone. So we will see now in the result that we use better the Borehole thermal energy storage if I cover all the building, okay? So we'll see three scenarios. The first one is related only on this zone, and then the second one with the three thermal zone, and the last one for all the building we simulating. Okay, this is a simulation we've done maybe last night in order to see something of thermal energy we recovered, and the electricity that we use from photovoltaic system in order to supply the heat pump. And we will also make a comparison between our, we can say, 3-generation system, maybe, with a traditional one, okay? And make a comparison between the pilot and the traditional one in order to cover the same demand of the final building. And so you can say the kilowatt hour of energy saving respect the traditional one, and also the cost saving. The cost saving are very small at the moment, maybe because we have to shift up, we have to go on simulation and not our study, but it's important to underline that we can have some energy saving, some energy mining. Okay. We also do this for the first one scenario, for the second one with the free thermal zone, and the last one will hold the zone. I want to show you other result in terms of energy that we recover from Borehole thermal energy storage. This is the same I said before with the comparison with the traditional one. Okay. Just have a look of the thermal energy that we recovered. If we cover the supply and the demand of only one zone, about 140 square meter, okay, because the total building is 500 square meter, we recover only the 30% of the thermal of Borehole. But if we increase the square meter to cover, to supply, we go until the 72% of thermal energy, but the temperature that we reach at the building is a little lower of the normal condition of thermal hygrometric condition, a little more. But we use the 70% of the thermal energy into Borehole, and the same. And at the same time, the heat pump, the electricity demand increase, because I have to use the heat pump more, and so the self-consumption is reduced. It's natural, but I'm able also to reduce. You have to pay attention that the thermal collector has only 4 photovoltaic panels, and there are 4 photovoltaic panels of 500 watt, and I can increase the efficiency of this one because of solar tracking of about 20%, so are 600 for each one. 2.4 kilowatt is very smaller. If I suppose maybe to put 2 solar collector with photovoltaic panels, I can increase this level. Okay. Also another information. This is the comparison in 2 particular days in in July and January, so the worst condition in winter, maybe in summer, and this is the predict the main vote is a parameter which is related to satisfaction of the final users. And if this value is more or less between minus 0.5 and 0.5 is a good value. And you can see in both days that this condition is satisfied. The other parameter is the percentage of this of the one we are not satisfied, and this value cannot go over the 10%. So if people over 10% are not happy, and also this value is respected. So with the one zone, I am sure that the conditions are good for the user, for the people who stay inside the building. So our conclusion, I have already told you. The idea is to shift up this result. We want to increase the temperature inside the Borehole. We also saw in the other Borehole we have already done at the University of Palermo, the temperature is about 38 to 40 degrees for 5 years, and we are sure of this one. So we also can joke with the flow rate. Maybe we can increase the flow rate of water in order to have a temperature which is very, very close to 35 degrees, and to use not so much the heat pump if I arrive very close to 35 degrees. So we have to manage this system, which is very particular 3-generation system. It's important to simulate different conditions, and then when we have already realized to try on our pilot. And for future remarks, we want to maybe to use an additional Borehole, maybe to have also cooling energy inside to use one for cooling energy and one for thermal energy. But it's maybe for the next project with Shadi within all of us. Thank you for your kind attention, and I